Here we're going to look at empirical formula calculations, and we've got a question here which is asking us to calculate the empirical formula of a substance that's got the following percentage of each element. And you've got 83.3% of carbon and 16.7% of hydrogen. Remember that the definition of the empirical formula is the simplest whole number ratio of atoms of each element in a compound. So what we're going to do then is you always make a column of each element in the compound. So I'm going to make a column for each of the elements, and in this case there's only two, so I'm going to make a column for carbon and hydrogen. I'm going to separate this by a line. Now, what you need to do is put down the percentage of each element in the column. So carbon is 83.3. Hydrogen is 16.7. I will say now that you may be given, instead of percentages here, you may be given masses, and you do the calculation in exactly the same way, whether you're given a percentage, like we are in this question, or a mass. What you do first is divide the percentage or the mass by the AR of the element. So the AR of carbon is 12.0, the AR of hydrogen is 1. Please do not divide it by the the atomic number. The amount of students that I've taught who've divided this by the atomic number, so they divided this by 6 rather than 12, well, it's too many to mention. We get, here's 16.7, and for this one, which I'll just move over, we get 6.94. So that's the first thing that we need to do, is get these numbers here by dividing the percentage or masses by the AR. We then need to divide these numbers here by whichever is the smallest, which is obviously 6.94. So I do 6.94 over 6.94. That's always going to give you one of these as an answer of 1. And this is 16.7 divided by 6.94. Now, in some instances, this will give you a nice whole number, and you get a whole number ratio at this stage. But in this instance, we get an answer of 2.4. So we don't get a whole number ratio. So the definition, remember, of empirical formula is the simplest whole number ratio, and obviously this is not a whole number ratio. So I need to do something to this number in order for it to be a whole number. And in effect, you just keep multiplying this number here by either 1, 2, 3, 4, 5. You just keep going until this is a whole number. Now, it's only when you actually multiply it by 5 do you actually get a whole number. So you need to multiply both these numbers by 5. Multiply both these numbers by 5 would give you 5 carbons and 12 hydrogens. So your empirical formula would be C5H12, and that there would be your answer. I will say now that, for example, if you did multiply both of these by 2, you'd have got 2 to 4.8. You cannot round 4.8 up to 5. Okay, you've got to be very, very close to a whole number, and 4.8 isn't close enough. So yeah, you times them by 5, and that gives you C5H12.